Look up. Feel the solid ground beneath your feet on this Sunday, the 17th of August, 2025. You are standing on a small, blue world, a precious jewel suspended in the vast, dark emptiness of space. Imagine for a moment that we could leave it all behind. We could begin a journey, a great outward voyage into the unknown. We start slowly, rising above the clouds, watching the continents and oceans shrink below us. The moon, our silent companion, drifts by, its craters a testament to billions of years of cosmic history. Mars, the red desert world. Jupiter, a colossal ball of swirling gas, its great red spot a storm larger than our entire planet. Saturn, with its magnificent icy rings, a spectacle of celestial mechanics. Now the sun itself begins to shrink. It becomes just another star, the brightest in a sea of countless others. We are moving through the Milky Way, our home galaxy. So what do we mean when we talk about the edge of the universe? It's a very human question to ask. We are used to things having boundaries, beginnings, and ends. But the universe is different. The edge we are traveling towards is not a physical wall. The edge we can see is a boundary in time, not in space. It is the limit of our vision, defined by the finite speed of light and the age of the cosmos itself. It is the edge of the observable universe. Imagine looking out across a vast ocean from a tall tower. You can see to the horizon, but you know the ocean continues beyond it. When we look at a distant galaxy, we are not seeing it as it is today. We are seeing it as it was when the light left it. The further we look into space, the further back in time we see. It is a cosmic time machine. The universe began about 13.8 billion years ago, in a moment we call the Big Bang. Just outside our solar system, we find ourselves in a vast expanse filled with stars. Our sun is just one of many, part of a stellar neighborhood. Some stars are giants, burning brightly and living fast, destined to explode in brilliant supernovae. Others are small, cool red dwarfs, sipping their fuel so slowly they will outlive the sun by trillions of years. We see emission nebulae, like the Great Orion Nebula, where massive clouds of hydrogen gas are being ionized by the fierce radiation from newborn stars, causing them to glow in vibrant shades of red and pink. These are stellar nurseries, cosmic maternity wards where thousands of stars are being born at this very moment. Then there are the darker clouds, the molecular clouds. These appear as black patches against the starry backdrop of the Milky Way. Planetary nebulae, like the Ring Nebula, are the beautiful expanding shells of gas shed by stars like our sun in their final stages. And then there are the supernova remnants, the chaotic expanding debris clouds from the violent explosions of massive stars. These explosions are how the heavier elements, the very stuff of which we are made, the carbon, the oxygen, the iron, are forged and scattered across the galaxy, ready to form new stars and new worlds. Our journey now takes us beyond the confines of our own Milky Way. We cross the vast, dark gulf that separates the galaxies. It's a journey of 2.5 million light-years to our nearest large neighbor, the Andromeda Galaxy. Through our telescope, it appears as a majestic spiral, even larger than our own. It is so close, cosmically speaking, that it is on a collision course with our own Milky Way. We see beautiful spiral galaxies like our own, with graceful winding arms filled with young blue stars and glowing nebulae. We see huge round elliptical galaxies which are often much older. These are reddish-yellow in color and contain mostly old stars, with very little gas and dust left for new star formation. And then there are the irregular galaxies, chaotic and lacking any distinct shape, often the result of galactic collisions or interactions. As we travel further, we encounter vast clusters of galaxies, cosmic megacities containing hundreds or even thousands of galaxies, all bound together by their immense collective gravity and surrounded by a halo of superheated gas. We see galaxies colliding and merging, a process of cosmic cannibalism where larger galaxies grow by consuming their smaller neighbors. We are witnessing the universe on its grandest scale, a dynamic and evolving place where structures are built and destroyed over billions of years. Zooming out even further, an incredible pattern begins to emerge. The clusters of galaxies are themselves not randomly distributed. They are part of an even larger structure, something astronomers call the cosmic web. Imagine, if you will, a gigantic three-dimensional spider's web stretching across the entire universe. The galaxies and galaxy clusters are not scattered like dust. They are arranged along vast, interconnected filaments of matter like pearls strung on an invisible thread. In between the filaments are the great cosmic voids. These are enormous, almost empty regions of space, bubbles of near-nothingness that can be hundreds of millions of light-years across. The cosmos is, well, kind of foamy, with matter concentrated in the walls of the bubbles. This cosmic web is a direct consequence of the conditions in the very early universe. Tiny quantum fluctuations in the density of matter just after the Big Bang were stretched to enormous scales by the expansion of space. The main ingredient of this web is not the stuff we can see. The vast majority is made of something we call dark matter. We cannot see it, we cannot touch it, and honestly, we don't know what it is. We only know it's there because we can see its gravitational effects on the galaxies and the gas. Dark matter forms the invisible scaffolding of the cosmic web, and the visible matter, the galaxies and stars, is just the froth that is collected along its immense structure. We have now traveled almost as far as we can. We are looking so far out into space that we are looking 13.8 billion years back in time. We are looking past the first galaxies, past the first stars. We are trying to see the moment of creation itself, but we can't. There is a wall, not of space, but of light. In the very early universe, for the first 380,000 years after the Big Bang, the cosmos was a different place. It was not transparent as it is today. After about 380,000 years, it cooled enough for the protons and electrons to combine and form the first neutral hydrogen atoms. This event is called recombination. Suddenly, the fog cleared. The photons were set free, and they have been traveling through the universe unimpeded ever since. Today, we see that ancient light all around us. It is the oldest light in the universe. Because the universe has expanded so much since that time, this light has been stretched to much longer wavelengths. It is no longer visible light, it is now in the microwave part of the spectrum. This CMB is not perfectly uniform. If we look closely with sensitive instruments, we can see tiny variations in its temperature, fluctuations of just a few parts in 100,000. These tiny hot and cold spots are incredibly important. They are the imprints of those initial quantum fluctuations, the seeds that would later grow, under the influence of gravity, into the vast cosmic web, the clusters, the galaxies, and ultimately, us. So we have reached the edge. We stand at the precipice of the observable universe, gazing at the faint, ancient glow of the cosmic microwave background. This is the limit of our vision. It is the horizon beyond which we cannot see. But what lies beyond it? Think back to our analogy of the observer in a tower looking out to sea. The horizon is not the end of the water, it's just the limit of your view. The simplest and most widely accepted idea is simply more universe. More of the same. Beyond the horizon there is simply more ocean. The theory of cosmic inflation, which is our best explanation for the properties of the early universe, strongly suggests that the universe is vastly larger than what we can observe. There would be other galaxies with other stars and potentially other planets with other observers looking out at their own observable universe. But we would be forever hidden from them, and they from us, beyond each other's cosmic horizon. It's a humbling thought. We may only ever see a tiny fraction of the whole magnificent reality. The edge of our vision is not the edge of existence. While more of the same is the simplest answer, science and imagination can lead us to more exotic possibilities. One of the most mind-bending ideas is that of the multiverse. This isn't just one idea, but a collection of different theories that all suggest our universe might not be the only one. One version, connected to the theory of cosmic inflation, is called eternal inflation. It suggests that while inflation stopped in our patch of space, allowing our universe to form, it continues in other regions far beyond our horizon. In this picture, new universes are constantly being created, budding off from the inflating background space like bubbles in a boiling pot of water. Each of these bubble universes could be vastly different from our own. They might have different laws of physics, different fundamental constants, maybe even different dimensions. Our entire universe, everything we can see and everything beyond our horizon, would be just one bubble in an infinite cosmic foam. However, some scientists have proposed that if another bubble universe collided with ours in the distant past, it might have left a subtle imprint on the cosmic microwave background. A strange cold spot or an unusual pattern in the temperature fluctuations could be a cosmic bruise, the only remaining evidence of a collision with another reality. This idea of a multiverse is deeply philosophical. It redefines our place in existence on the most fundamental level. Our journey is at its end. We have traveled from our home, a precious blue dot, to the very edge of sight and time. We have witnessed the birth of stars, the waltz of galaxies, the grand architecture of the cosmic web, and the faint ancient glow from the dawn of creation. We have stood at the boundary of the known and peered into the abyss of the unknown, asking what lies beyond. What we do know is that the universe is far grander, stranger and more magnificent than our ancestors could ever have dreamed. The story of the cosmos, as revealed by science, is the most epic tale of all. It is a story of creation from a point of unimaginable energy, of the slow and patient construction of structure by gravity over billions of years, and of the emergence of at least one place, our Earth, where the universe has become self-aware, able to look back on itself and wonder about its own existence. The iron in our blood and the calcium in our bones were forged in the hearts of stars that died long ago. We are, in the most literal sense, stardust, and we are the means by which the universe can contemplate itself. When you look up at the night sky, you are not just an observer. You are a part of that cosmic vista. You are a participant in this grand unfolding story, and so we are left with a feeling of profound awe. The universe does not end at the edge of our sight. Our knowledge does. There are still vast mysteries to solve, new horizons to explore, and deeper questions to ask. The journey of discovery is far from over. The great silence of space is not empty. It is full of unanswered questions and untold possibilities waiting for us to find them. And the quest to know the cosmos is, ultimately, a quest to know ourselves.